I'm glad to organize this session about data science. I'm here, by the way. Sorry. We have 4 speakers today, and I will start by Andreas Meyer from FAUL. And Andreas, you will introduce yourself alone. It will be easier because like this, I will not make too many mistakes. We have Gilles, Adda, Valerie, Gouet, and Jean-Michel Marin. Probably let's start with a very short presentation of each of our speakers. Please, Andrea, introduce yourself.
Yeah, hello, my name is Andreas Meyer, and I'm a professor of computer science with focus on pattern recognition at FAU Erlangen, Nuremberg.
Valerie.
Hello everyone, I am Valerie Gouet-Brunet. I am a senior scientist from the Ministry of the French Ministry of Ecology, and I work at IGN, the French mapping agency, within LASTIG laboratory, and we are also attached to the University Gustave Eiffel in Marne-la-Vallée, close to Paris. And my main research activities concern content-based image retrieval, with current main applications to the indexing of cultural and natural heritage.
Okay, please, Gilles.
Hello, my name is Gilles Adda. I'm working in CNRS laboratory, where I'm the head of the Language, Science and Technology department. And my research area is natural language processing, and mainly I develop language models for speech recognition and translation.
And Jean-Michel.
Hello, I am very pleased to be here. My name is Jean-Michel Marin. I am professor of statistics at University of Montpellier. I am also the head of the French Statistical Society. I will speak about the French Statistical Society in a moment. My research area are Bayesian statistics, model choice, importance sampling, let's say numerical probabilities, and my main application are concerns with population genetics.
Okay, so the journey will be organized as follows. Everyone will have 10 minutes to introduce a little bit more himself by showing some application he's working on. And then we will have mostly 2 questions about COVID-19 museum. Before this question, I will shortly recall the organization of the COVID-19 museum and how it is built or how it is imagined. And then the 2 questions will be, in case of such COVID-19 museum exists, what will be the interest for you and how you could provide help to the construction of a such COVID-19 museum. So probably let's speak to Valerie.
Okay.
Yes, if you are ready.
Okay. Yes.
It's fine.
So I try to share my screen.
Yes.
Where is it? Yes, it's here. Can you see my screen?
Yes, perfectly.
Okay, so I have a lot of slides. You will have to stop me probably. So I'm Valerie Gouet. I work at IGN. And I did not told that, and I am also attached to the Time Machine organization. I don't know if you know this organization, which is a European consortium dedicated to the big data of the past. And so some applications that will be shown here are done within the scope of this area. So first, just a little comeback to what is IGN. IGN is a French mapping agency. It's a French public institution, which depends on many organizations, many ministries, French ministries, mainly the Ministry of Ecology. And we have two main missions: the production of accurate and neutral geographical information, which guarantees national sovereignty, and also the study and development of new reference system, product and geoservices for meeting the growing, evolving needs of spatial information. So we deal with everything which is related to spatial information and which describes the French, mainly the French territory. We have, I have to move. Okay, it's okay. So we have, of course, you probably know IGN for the paper maps. If you go to have a walk in France, maybe you will use the paper version of the maps. And we have also the French geoportal, and maybe someone of you know this portal. But it not only, we have a lot of spatial and multidimensional and multimodal information, which evolves with the years, of course. And we work with a lot of different categories of maps. It can be maps with different layers that describe many different information. So we can go up to 3D maps. I don't know if you see my mouse, but because I try to show
your
with,
mouse.
okay.
We see your pointer without any problem.
Okay. We have also a lot of images. It can be vertical, aerial images. It can be oblique images also. We have also very high resolution images, as you can see the Eiffel Tower here. We have also much more than maps, 2D maps and images. We have also 3D models. You can see here different kinds of models. Basic 3D models of buildings, but this is basic, but we have it for all the territory. While here you have more complex with more details, 3D information, but which is not always available on all the territory. And we go mainly in research because we have a lab of research. We go much more deeper by considering also 3D information and new acquisition systems. For example, you can see here our mobile mapping system, which can capture the street at the street level information, photometry images, and also 3D geometrical information. Here you can see LIDAR, points, clouds, acquisitions of the city. For example, all Paris was acquired like this with such kind of information. And we also exploit such data with photogrammetry and computer vision tools, for example, to obtain some 3D very precise models of monuments. Here, Notre Dame, and here, Château de Chambord. It's not all, because we deal also with past information. Here I have some statistics about what I call the big geodata of the past in reference to Time Machine. Here you have a survey. You can see the number of surveys that were done in France, and some of them began at the beginning of the last century up to now, where the information is digital, more digital born, of course. But we have a lot of multimodal, multi-date information to our our disposal. At IGN, we do research. We have a laboratory in science and technology of information, geographical information, where we do 4 main areas of researches. I don't read them here, you can see it. And I will focus more on the first group where I am, and more precisely in image indexing and retrieval, because you see that we have at our disposal a lot of very heterogeneous, very large data set of contents. And I work more precisely in solutions to index them, to browse them, to restitute them easily to the user. And I focus on this topic because I think it is the most relevant for the COVID-19 museum. So maybe I have time to just explain what is content-based image indexing. Tell me if it's not the case.
Sure, go ahead.
Sure?
Go ahead.
Okay.
No problem.
And so I work on content-based image retrieval. The acronym is CBI here. The idea is to describe and index the images by analyzing their content. Usually when you use Google to find images, you have to put some keywords, and the system retrieves for you images according to the metadata, to the environment, the textual in general environment of these images. And now here we work slightly differently. It's a complementary approach, of course, not to replace the textual one. We work by analyzing with processing and image analysis methods the content of the image in order to extract visual characteristic, of course, according to the task. It can be the idea of describing the colors, the distribution of colors in the image, describing the shapes of the image, describing some details of the image. And finally, the image is represented by a vector, a multidimensional vector, or a set of multidimensional vectors that include information, a description of such visual characteristics. And then each image is described with these vectors. And we can compare images, retrieve images, compare an image with a model by using such information. Globally speaking, a system for search and retrieval of images works like that. You have here a data set of images. Each image is associated with the signature, the descriptor, the vector I have just shown, which is put in a big multidimensional feature space. In general, it's a vector space, but with 1, 2, 3 hundreds of dimensions, or more than that. And from the other side, you have a user who, for example, uses the paradigm of query by example. He gives an image to the system. For this image, we compute his vector, his signature, which is compared and retrieved by similarity in this big feature space. And then the system returns to the user a set of images that correspond, that are the closest neighbors of the query image in this space. And the system so retrieves the most similar images. More concretely, I can show you some example with IGN images. Here you have a query. It's at Créteil, some famous buildings in a city close to in Paris area. And so the system retrieve those images. It is the 10 first images here, ranked by decreasing order of visual similarity. So the descriptors here were built according to a particular task, which was retrieve the same buildings despite the potential differences of viewpoint, of illuminations, etc., etc. So here you have some other example. I think it's a place of Charleville-Mézières. I'm not sure, but it should be Charleville-Mézières, another French city. And so you can see that with the descriptor used here, but of course you can change the descriptor, the system retrieves the images of the same scene in different conditions. Here the season is different, the point of view is different, the illumination is different, etc., etc. Some other example. Okay, it's the basic concept of content-based image retrieval. And why are we doing content-based image retrieval at IGN, or more generally, why is it interesting to use such tools? The main idea is the capability of interconnecting image collections independently of the metadata. Some collections have great metadata, other collections don't have very precise or relevant metadata for a given application, which can be an application different from the one where the first set of metadata were acquired. And so interconnecting collection by using only their content may be relevant for many applications. Maybe I will have time to show them later. And so you can use such kind of tool for a lot of reasons, for gaining in accessibility and visibility of your data, for being able to structure, to give consistency within a collection and between collections. For example, I work with some museums and some an archive, French National Archive. And with such kind of tools, you are able to interconnect, to link images from one site, Archive National, for example, and to be able to say that such an image is in relation with such another image which comes from another museum. So you have the capability to structure the information between collection and in a collection and between collection. Of course, if you are able to link this data, you can propagate information. For example, annotations. I will show an example later. You can also, as an extension of annotation, you can also spatialize the photograph. You can provide an information of localization on the images while you did not have this information before. And another example here, I don't work on this topic at IGN, but I worked a lot on it before I was at IGN. So I put it here in parentheses, but I have example to show also. You can work on you can use these tools for copy detection and monitoring of images. So I have put this list here because I think it represents tools and applications which can be relevant for COVID-19 museum. So I can stop here, or I can go deeper with, I am responsible of a project which is called Allegoria. And I can provide a lot of examples of what I just said within this project. But tell me if you want, I talk about them now or later.
Valerie, what I propose is that you keep this for later, such that we start the table. Andreas, perhaps because as already Valerie speak about Time Machine Europe, probably it would be of interest that you introduce yourself and introduce Time Machine Europe.
Yes, I can do that.
And just for people who would like to ask questions, I think that we will finish this short presentation of each speaker, and then if you want, you will have time to ask questions to Valerie, Andrea, Gilles, and Jean-Michel. Because I have seen already that Slava has a question for Valerie, so just Slava, if you can keep it, and such that we have a short vision of everyone. Go ahead, Andrea.
Yeah, thank you very much for this opportunity. And I want to introduce a little bit the European Time Machine Project, and in particular contributions that our group is bringing in terms of methods. And you will see that there is a lot of relation to what Valerie already presented, because we also collaborate very closely in this framework. So I'm also a member of the executive committee of the Time Machine, but of course I'm primarily a professor of computer science in the Friedrich Alexander University Erlangen Nuremberg in Germany. And you can also find me on social media if you follow this tag here. So this is where you can also then start discussions and discuss possible research and so on. And what I want to present to you is a large-scale project, a very ambitious one, and it's called the European Time Machine. And European Time Machine essentially wants to enable a virtual journey through time and wants to make 2,000 years or more than 2,000 years of European history accessible. And this means that within this project, we need to make a lot of data accessible. And this would essentially then bring us to a stage where we can also speak about big data of the past. So with big data of the past, we mean that we also want to be able to do big data processing, but not just with present day data where we have abundance of data available, but also get into a state where we can work with data that is available about the past. And the big problem with that is that if you take an overview over, sorry, I'm not sure if you can see that animation well.
Yeah, see your animation.
Does it work?
Yeah,
So
yeah,
what you see is that over time in present day today up here, there's lots of data available. But the further you go back in time, the fewer the data is available. Now, if you would digitize, you can make this better. But ultimately, if you want to go beyond the Middle Ages into ancient times to understand them better, you will probably have to rely on means of simulation, because there is only very few objects available and very few knowledge. And even if you digitize a lot, the situation might not improve a lot. Within these efforts, we have already across Europe different initiatives that started now locally to build their own time machines. It essentially are repositories that make data available about their cities. So you see they're essentially mostly predominantly focusing on cities. There's Amsterdam, Antwerp, Budapest time machine. There's a couple of regional ones like around Naples. And you see that there are a lot of cities that got inspired by this idea and they are trying to make their data available. And later the whole system should then be combined into a time machine where you also have access to the different cities and interlink them and also draw connections between them. So it's a huge, ambitious project. This was actually planned to be an FET flagship, and we were aiming at getting 1 billion euro of funding, but unfortunately the mechanism was stopped. So the project was doing extremely good, was onto the final 6, and actually the project with the highest score. But unfortunately, the European Commission decided within Horizon Europe, there won't be FET flagships available anymore. Still, the consortium is living and we are still actively recruiting new members. But now we are driving this bottom-up strategy. And this is also why the connection here to COVID Museum is very, very important for us, in my view, because that could potentially be another local initiative that we can link together, and that could be potentially a COVID-19 time machine, you could say. So it would be nice to then establish joint interfaces and make this data available again, because I think it's a very important topic. So what I want to show in the remaining minutes are a couple of contributions, and we'll go through them rather quickly because these are essentially methods like building blocks that we want to contribute to Time Machine. And again, as we do a lot of images, image processing is important for us. And one idea that we developed with other Time Machine partners is the idea of the book CT. So sometimes books are destroyed beyond the accessibility of opening them. So if there was a fire, for example, then just opening the book might destroy it, but also sometimes letters fall from the books when you open them. So this may also happen. And therefore, even opening the book may be a threat to its contents. In these cases, we can work with the idea that some of the ancient inks, and to be honest, actually quite a few of them, they contain iron particles or metal particles. There's 2 different types of inks that I'm showing here. And if you do so, you can actually use computed tomography, because computed tomography is very, very sensitive to metal. So you get very good signal. And then the idea that we start working on is placing the entire book onto a turntable and scan it with X-rays without ever opening it. and then virtually take the volume. So there's a 3D image generated that at every three-dimensional position knows what kind of density is present there. If you just slice through it with a conventional scanner, you can't read the pages because they're partially overlapping. So it's very difficult here on the left-hand side. But you can take the pages, segment them. And by segmentation, we essentially locate every page in the book. And then you can see we can identify the different pages, and then we do a centerline extraction, then virtually flatten the page, project it onto a two-dimensional image by compression, and the result you can see here. Here you see a couple of inks on the top on a facsimile that we produced in order to test our algorithms. And on the bottom, you see the pages extracted with the algorithms that you see here. So we can even access completely inaccessible information of this. And then, of course, we do things that are very similar to what Valerie has been showing here. Instead of buildings, we've been working with writers, and we want to find out who wrote which text. So we have essentially a text that comes in, and then we have a database of known persons where we know who has written what text. And then we want to retrieve either the most similar writers or pick the most similar writer, which would then be writer identification. And we applied this in contemporary and in historical data, and the results over the past years have been increasing. The approach is very similar to what Valerie already said here. So we're using essentially a feature extraction approach that then data-driven extracts local descriptors, and this can then be united in a global descriptor. And over the past years, we have seen that the recognition rates could be increased quite dramatically, such that we have now close to 90% recognition rates of writers. So this is a very useful technique if you want to figure out who has written what and you want to find relations between the writers. We are also looking into changes over time now, then because the writing changes over the years, and therefore it could also be interesting to develop a model of how a writer can actually have different means of expressing himself over varying times. The same models can also be used not just for recognition, but also for generation of writing. And this is an example where we generate writing just using a text. And if we know how the handwriting looks like, we can create essentially writing that looks like the writing of a different person. So this is also a good point to keep in mind, that all of the technology that we're developing, they also have side effects. And as you can use a technology to uncover the past, you can potentially also use that technology to create false information about the past. So this is something that you should always keep in mind when you're working with these methods, that they can be, of course, be used for good purposes, but there might also be side effects that can bring you in a situation where they can also very easily used in order to create fake documents. Obviously, not just handwriting, you can also parse or interpret different fonts or text recognition. You have the problem that even in printed text, the variation is very high of different fonts that have been used. And therefore, my colleague, Matthias Soré, he is working on techniques also based on deep learning that then allow to create the probability of a certain font being used on a text. And here on the left-hand side, you see an input that is actually using two different types. So it's not just one typesetting that is used, but there's two different sets of characters. So on the right-hand side, you see that there's about 70% Antiqua, but also 40% of italic. And he also worked on methods to use this classification result and backpropagate it through the network, such that you can identify the areas where the certain type has been used. So also things like this can be realized with image processing methods. And what's also very nice about this is it essentially gives you a map of distances. So you can also use it to visualize and create clusters. And generally, you can not just do this for types, but for general images. And again, this is very similar to what Valerie already showed. All the methods that she has been working on can be used for very similar purposes. But it's another approach how you can extract data and knowledge from many observations. And last thing that I want to show here is more going into images and paintings and prints. And here we are actually showing the some images of Martin Luther. So everything here shows Martin Luther in different ages and positions. And now we are interested in the serial production processes and also how the prints change over time when you do multiple of the prints with the same plate. Can you find the sequence in which the prints have been produced? And this can also be done by analysis of image registration. You try to map them into the same space, or you do similarity analysis on repeating elements. And here we see repeating motifs. And just to show you what is possible, I have one example here where we use essentially facial recognition. We identify the eye, the nose, and use this as a feature to map the two images into the same space. And here you can see a result of such a mapping. And it's quite striking that you see this high degree of similarity between the two paintings. And this then raises questions of whether the same source has been used or whether the same template has been used in the production process. So this similarity, also the view angle, is so similar that we would assume that there was some measure in place that links the two images. Yeah, and the last thing that I want to remark on, we are also working in the Ordre project, and in Ordre, you see the URL up here. We also want to go even a step further, and it's not just that we are interested in image analysis, but we also want to use the image analysis to get cues about how the sentiment, and in particular here, the odor and the scent, was probably in the scene, and we're collaborating here to use that with artists of scent. They can synthesize and recognize scents very well, and by doing this analysis, we are experimenting whether we can also get the aroma, the scent, re-synthesized for a particular scene, and we use that essentially by a multimodal cooperation here, that we try to find specific items in the image that would be surrogates or markers of specific scents. And then we try to mix this in this huge European effort. So we are only doing a tiny part in here in order to re-synthesize the scent that has probably been around when this kind of scene or image was actually generated or painted. So this already brings me to the end of this talk. Obviously, COVID-19 museum is a great idea. I'm absolutely convinced that it's necessary to put up an initiative like this. And I hope that in the future, the software tools for analysis of drawings, paintings, even handwriting, text, language, but also moods and emotion could be very useful to work on such data. Obviously, I can't answer the questions that potentially arise with access to such data right now, but I think it is worthwhile to think about what's technically possible, which information can be linked, and bring these things together in order to build new insights over the COVID-19 pandemic. So thank you very much for listening. If you're interested in the European Time Machine project, you can reach us in social media, on Instagram and Twitter, as well as on our website. Thank you very much for listening.
Thanks a lot, Andreas. It was really interesting. Probably we will go directly to Gilles now. We don't hear you, Gilles. You need to open your microphone.
Thank you. I should say that I didn't prepare so much detailed slides. I just prepared some slides about well, what we are doing in our laboratory. But I think that thanks to all Google and Apple, everybody is familiar with speech recognition and translation and so on, and chatbots. So I come from the laboratory LISN, Laboratoire Interdisciplinaire des Sciences du Numérique, which was created in January 1st, 2021, from the team of the computer science laboratories of the University Paris-Saclay, in Similarity. It is a CNRS laboratory. There are around 400 people, half of them sorry, in a permanent position. Well, the laboratory has a very broad scientific spectrum and 5 departments. I will not detail here to focus on well, the department I'm responsible for, the language science and technology department. So, well, as you can see, in our department, the main word is language. We are using well, AI and so on, but this is a real language department, which means that what we are interested in is the language, and that means that there are a lot of computer scientists, but also a lot of linguists. And if you deal with language, that means that you have to go from signal to meaning, and so vice versa. And also that all languages are worth processing. So all spoken, written, sign, technical accented language, regional accent, and all the languages of the world, not only French and English. And the methods we used are very similar to what was proposed by the other colleagues. So, which means that we are looking at the data and with a bottom-up approach, and using machine learning techniques and deep learning and so on. And main applications are very standard applications, speaker identification, speech transcription, chatbots, machine translation, and question and answering systems, and so on. As I said, we are dealing with fundamental research from corpus linguistics, and which I think it is relevant for the subject here. So using the system we are building as instrument to look at the data. And also, well, we are dealing with machine learning for a very long time. The LIMC was created in the 70s, and we are dealing with speech recognition since the 80s. So we are dealing with machine learning from the very beginning. I will not detail the application. As I said, they are very common. And as I said, what should be, which is very important for our department and in the laboratory in general, is that we are dealing with all modalities and all genre and registers and all domains, and not only the languages which are well resourced, such as French and English, but also well, under-resourced or even non unwritten in endangered language, African language. So we are working a lot on language documentation with linguists who are going to Africa to document well, language spoken by a few dozen of people. So the main peculiarities of the NLP at LISN is we have two groups, and which represent well, a quite large center for language technologies. we are using corpus-based processing and machine learning. Well, just there to, well, it's represent about 60 people, which is quite large for research, but very small if you compare that with what are doing the GAFAM. For instance, at Amazon, it is said that there are about 10,000 people working on language. So, and that's all for me.
Thanks a lot, Gilles. And last of this table, Jean-Michel.
Yes, I'm ready. Let me perhaps first speak about the French Statistical Society.
Gilles, tu dois fermer ton partage.
It's okay for you, Eva? I speak.
Yeah, sure.
I introduce the French Statistical Society, and just after I will give some slide of my research of what I am doing as applied research in population genetics. Just few slides. In order to not only introduce a society, but also some things related to research project. Okay, so everybody can see my slide?
Yeah, you can.
Okay, perfect. So what is the French Statistical Society? The French Statistical Society, its goal is to bring together all researchers, engineers, teachers, and users of statistics, whatever the nature of the duty and the place where they exercise them. And the French Statistical Society is a privileged place of meeting, exchange, and reflection. The society has been founded in 1997 with two main goals. The first one is to promote the use of statistics and its understanding, and the second one is to promote its methodological developments as classic national society. So we are recognized of public utilities, and we have some internal segmentation. Our forcing group are at the core of the society, and we have many. The group are either thematics or more associated to a methodology. You have, for instance, an agro-industry group, a bank finance insurance group, a biopharmacy and health group, chemometrics group, survey model application group, teaching statistics groups, environment and statistics group, reliability and uncertainty groups, a group on history of statistics, probability and their use, a youth statistician group, a machine learning and artificial intelligence group, mathematical statistics group, statistic and society groups. This group is related to try to diffuse the statistic idea in the society and take initiative regularly to encourage the production and dissemination of statistical information and to foster exchange between professional statisticians concerned with defending the role of statistics in society. So this group play a very important role in the relation between the society and the French statisticians. And we have also a statistics and sports group. The French Statistical Society has about 1,000 members. So each member can be associated to one or more group. And we have also electronic and open access journal and books. And I would like to introduce more deeply our new journal, which is called Computo. 1 year ago, we have two journals related to survey and methodological statistics. The one which is called the Journal of the French Statistical Society, and the other one more concerned with case studies, which is called CSBIGS. And now we start with a new journal in place of this two one, which is called Computo. And Computo has been created in the context of reproducibility crisis in science, which typically calls for higher standard in the publication of scientific results. And Computo aim at promoting computational algorithmic contribution in statistics and machine learning that provide insight into which model or method are the most appropriate to address a specific question. And it's a free for readers and authors, and it's open journal which highlights reproducible contribution. The reproducibility of numerical results is a necessary condition for publication in Computo, and submission are not as standard because the submission are notebooks like Martin or Jupyter. So we introduce this new journal to favorize typically reproducible contribution and also totally open access journal. We also used to have a statistical education journal, and we now merge this journal with our journal, which is called Statistics and Society. And this new journal is concerned with more applied things and with the impact of statistics in the society. The French, Statistical Society organizes also a lot of scientific events. The main one is Journée de Statistiques. It's an annual meeting. It's the largest scientific event of French-speaking statistical world. More than 400 researchers, teachers, and practitioners. We have also some sort of doctoral training. We have also organized events of meeting between young statisticians, a focus on mathematics trade in all sectors, see with Forum Emploi Math, and also Atelier Statistics provide user tools and methods to improve their knowledge. The society also award prizes. I don't want to develop this part. And with respect to the COVID Museum project, perhaps Yves, I will explain in few slides later why the society strongly supports the COVID Museum project, or I do that right now. I think it's better if I do that after you recall what is the project, no? We cannot hear you, Yves.
Yep, yeah, it's perhaps the good way that I recall the project just with two slides, and
then I can explain why the society, the French Statistical Society, takes this this very important decision to strongly support this project.
Yeah.
Okay.
Sure.
Just a few minutes. To introduce some more research things with respect to my research area. I am involved in research on population genetics for 20 years. And my goal is to try to develop some inferential process and to select and to discriminate between demographic history using a genomic polymorphism data set. Population genetics is concerned with the cause and effect of genetic variation. And we have a modern genetics theory, which is a coalescence theory. And the goal is to predict and understand the evolution of gene frequency in populations. The goal is to recover some element of the population history and to analyze the structure of genetic data. The coalescence method is very important, and this method you use the gene trees here, and the formulation of a model is constrained of an evolutionary scenario that mimics the historical and demographic reality. And such a scenario summarizes the evolutionary story of population by a sequence of demographic event from an ancestral population. And the dataset we observed is genetic information observed at the present time. We have more and more information, more and more locus, more and more genetic information. And we can consider that this genetic locus position on the genome are independent or not, but there is a lot of debate about this assumption. But if we can consider some independence lossy, but we have to work to have this. And there is a class of probabilistic model, which is the coalescence process. The coalescence process is a neutral model. There is no effect of selection. And so the observed polymorphism at the present time is a result of genetics mutation on the genealogy of individuals. And with this model, we can answer some different type of biological question, estimate divergent time, quantify a reduction or increase in effective population size, infer migration rates. This is parameter estimation problem. And there is another class of problem which are more concerned with model choice question, which is, for instance, determine from which ancestral source come a population, describe some route of invasions. So there is this very nice example in human population example. We have 50,000 SNP marker genotyped in 4 human population, a population from Africa, one from East Asia, one from Europe, and one from American individuals of African ancestry. We have some individual per population. If you have only 30 individuals per population, the data set, as we have 50,000 SNPs, is a vector of length 6 million. Yeah, so not so big, but quite big. And what we would like to do with this vector of genetics information of size 6 million is to try to discriminate between different scenarios. The first one is a single out of Africa colonization event given an ancestral out of Africa versus, for first hypothesis, versus 2 independent out of Africa colonization events. And also another things we would like to infer is the possibility of a recent genetic admixture of American or African origin with African ancestor and individuals of European and East Asia origin. So you have this scenario, and we try by using genetic information at the present time to discriminate between these different scenarios. Okay, so you got this. So you have this data set, you have a model, you have this coalescence theory, which give you a model, and we have a lot of hypotheses about independence of losses, the type, and we have some asymptotic approximation of a discrete model, which is called the Wright-Fisher, the very nice Wright-Fisher model, which is the coalescence. The Kinman coalescence is in fact an asymptotic approximation of the Fisher coalescence model. And then we have also a model for each population and a model which describe interpopulational events. We can consider some divergence, admixture, migration. Here we have a divergence between an ancestral population and an East Asia population and the other population, African one. Here, American of African origin and European one. So you see, and you can have also some sort of admixture, some sort of migration between population, and we have a mutation process. So you have this big model until the most recent common ancestor for each locus. We have this big model. And we have typically some inferential difficulties. We cannot calculate the probability of what we observe at the present time. The reason is that this probability depends on the unknown genealogy of gene. And this genealogy of gene, you cannot integrate this genealogy of gene. So you cannot use standard inferential process. You have to be more creative and use some other sort of process. And the reason why is because this integral is of very high dimensional integral with discrete and continuous parts. And despite its very simplicity, the Kidman coalescent and the mutation process, we cannot expect any simplification in the calculation of what we call the likelihood, the probability of what we observe. And then we have developed a set of technique which is called approximate Bayesian computation. And we avoid to approximate the likelihood, and we simulate from the model and compare the simulation data set from the model to the observed one in a clever way, using some machine learning techniques like random forest of neural net. And we develop software. So, okay, so it's just to not speak only about my responsibility about the French Statistical Society, but to give also an application of what we are doing in our lab in Montpellier. We work in connection with some population genetics guy to do this type of research. So Yves, I can stop here, and if you want, in few minutes, I will explain why the French Statistical Society takes this unhabitual position to strongly support a research project.
Yeah, thanks. So at least with your talk, we have had a vision of the diversity of data science, going from mathematics to real application in language or in image processing, also in history. So it's very interesting because even if your presentation was clearly more mathematically challenging, it was talking about the same thing. And just before to open the discussion, I would like just to recall what is about the COVID-19 museum. For this, I will just share my slide. So sharing. And Andrea, I'm sorry, I have not taken the slide in English, so you will have to support the French version. First of all, the COVID-19 museum has been, I have imagined this project around the 22nd of March. And I have called some colleagues, I have a trace that I have called some colleagues by email the 25th of March. And give this information inside my university at the end of March, the 30th of March. Whether the UNESCO called quite early, it was already in April, to transform the threat of the COVID-19 in a way to support the patrimony, or whether it was just about official document here, and only official document. Similarly, the 15th April, the New York Times was asking what historians will see when they will look backward on the COVID-19 pandemic of 2020, which is quite funny because 2020 for COVID-19, you know that the 19 from COVID-19 is coming from the fact that the pandemic has started in 2019. So this was the picture at that time. And when I have imagined the COVID-19 museums, straight from the beginning, I have imagined it should be a collaborative project devoted for three things: memory, pedagogy, and analysis. And from these words, I have imagined that this project should be built around what I have called a CAMPA, The brackets are here for recalling that we have been confined at this period. So this was the picture, developing a collaborative archive for the memory, for the pedagogy, and for the analysis. So what is the COMPA? The COMPA is a software developed in open source, which could be used over any collection of documents or any computational resources. It would be the software to build the COVID-19 museum. It will have inside an interface to access the content of the COVID-19 museum, and the content of the COVID-19 museum is all the collection put together, and at the same time providing the computational resource to be able to focus using data science on this data. Focusing means exactly what has been described earlier by our four speakers, meaning really use the data to infer and to provide new information. So just to understand the construction of the COVID-19 museum, so the COVID-19 museum is this entity which is indeed an empty entity. It's only developed this software COMPA, and it is used to unite the collection of digital artifacts. What is important is the squared which are around this COVID-19 museum, because these squared around the COVID-19 museum are the active part of the COVID-19. They are made of collections, so if a collection installs the COMPA over its resources, then the collection shared the data that it contains. If a university, a data science center, or even an individual installs the COMPA over its computer, then it can provide some computational resources for the COVID-19 museum. Finally, if researchers are installing the COMPA, they can access the data and they can ask inside the COVID-19 museum some processing of the data in order to retrieve information. So if we synthesize all the process, the COVID-19 museum is an analytical tool, and it's built with the actors which are at the basis of the COVID-19 museum. So it's unified the collection of digital artifacts in link with the pandemic. It provides the opportunity to analyze in a reproducible way this digital artifact. It creates a link between the ontology of all the collection, and it protects the knowledge which will be extracted from this data. Whether it doesn't change the museography of each collection, it doesn't organize the collection, it doesn't analyze the collection, and it won't be what I will call judge and part. So this is the way the COVID-19 is imagined. It's a global project about this period, and in some sense, with respect to what we have seen earlier, instead of developing the process in the whole history, instead of being one point of one city along the history, it is one point in time, one single point in time, as with respect to what Andreas has presented, which is imagine over few thousand years. What we can expect from COVID-19 period is that it will be much, much shorter, probably less than 10 years, or whether it has had an impact on a surface which is clearly much larger than the city Andreas was talking from. So this is the idea of the COVID-19 museum, short period in time, or whether a very large surface in terms of geographic impact, political impact, etc., etc. So now I propose to start the discussion, and perhaps we can start this discussion by asking to our four speakers how they imagine that the COVID-19 museum can be useful, and how they can imagine that their tools or their methods can help the COVID-19 museum. And because Jean-Michel is presenting the society, the French Society of Statistics, and because the French Society of Statistics has provided support, a very strong support to the COVID-19 Museum project, I propose that you start this discussion, Jean-Michel.
Yes, thank you. I have just few slides about your question, so very few. We discussed in the board of the French Statistical Society, and typically I start with the conclusion. Typically, the French Statistical Society in French is called SFdS, is not intended to support and label research activities. We have been asked to support research activities, but the typical position is to not enter in this type of things. But we change a bit of our viewpoint, but just for the COVID-19 museum project, and I will explain why. So in our comprehension, the aim of this project is to carry out an almost exhaustive collection of digital information of all kinds disseminated during the pandemic. So we very strongly support this project for the main reason is that such a collection would constitute a very rare example of a photograph of a world event with very multiple dimensions. We have some health, political, scientific, economic, social. So it's very rare and extremely rare that such a collection of a photograph of a world event will impact a lot of different dimensions. So this is the first reason why. And also, in our opinion, this project is made possible by the nature of the targeted information. And it's also particularly relevant for an event that is limited in time. So there is a photograph. You start at time 0, and then in 4, 5, 6 years, you collect all the information, and with this information, we will impact. We could impact a wide range of discipline, and there is very few examples of projects of such a scale. We can get some invaluable information for researchers for very different disciplines, And so after a discussion in the board of the French Statistical Society and also in the council, we decide that the scale and the nature of the COVID Museum project made us depart from our rule to not support and label research activities. And at the end, the French Statistical Society has written some letter to Yves to very strongly support the COVID-19 museum. So that's the main reason is very multiple dimension, and the fact that a wide range of discipline can be impact and can be interested with this data.
Thanks, Jean-Michel. Thanks a lot, Ivan. Please, Andrea, would you like to follow?
Yeah, so I think what we can do is with data is we can help to answer research questions. Obviously, the questions have to be brought up in order to answer them. And I think data science is a tool that can be very useful. So for example, we could link different images or paintings or all kinds of data with each other. And I think this is a great opportunity that comes from the COVID-19 museum, because you will be able to establish those links. And I think this is going to be a really great opportunity and a great framework to enable future research. Linking this with data science technologies will essentially just make it more valuable.
Valerie, you would like to add a few words?
Yes, exactly. It was already said. So I'm going to speak in terms of image collections. And in terms of image collections, of course, we can think in terms of tool, as I presented slightly at the beginning, in terms of tools for structuring, accessing, or interlinking collection of images. And for a data scientist, the COVID-19 museum can provide a new context with multiple dimensions of information that can be exploited to improve or to develop different kind of tools for interlinking those image collections. So it's very relevant because the bottlenecks are different, the scientific challenge are different. What I wanted also to say is that when I think to images through the COVID-19 museum, through the pandemic, I think about two things, two directions. The first direction is, of course, to provide tools for better gathering information. And also, I think in terms of applications also. If we gather such kind of information, we can also change things in terms of new application. For a concrete example, in terms of tourism, if we think that we were not able to travel because of the crisis, in terms of tourism, maybe we have to think differently how to travel, how to do tourism, how to do cultural or not cultural tourisms. And acquiring, interlinking, structuring collections of information may help to develop such new kind of activity, for example, virtual and sustainable tourism. And so it opens the way to the door for new kind of applications also.
Thanks. Gilles, would you like to add a few words? And by the way, as you are also in ethics, if you want to add at the end a few words about ethics, you are welcome.
Well, yes, I think it is very important to to have all this data accessible for researchers and especially in humanities. So well, maybe you should ask to researchers in humanities to see if it is really important. But well, I think it is important to have this way of thinking. What we call the big data approach. Well, it is funny that we now in computer science we do not speak about big data, but maybe in data science or even artificial intelligence, big data is outdated, not trendy anymore. And it is very similar to the metadata you put on the document. It is exactly the same thing, but if you speak to humanities, you speak about big data, and now for computer science, you speak about data science. So it's well, so it's the content is very similar, but well, it goes to maybe to my point that I am dealing with unstructured data. So well, that's for images or so. I think it is very important to make it accessible to the researcher, all the unstructured data. So all the audio and video testimonies, films, report, and so on. You may have some metadata, but maybe you don't have all the information, and you don't have the information maybe the researcher want to have. So you need an a priori to build the metadata. So to make all the data accessible, all the content of the data accessible is, to my point, very important. And I should say that, well, maybe I should say that it is important to stress that AR or big data approaches should not be regarded by the researchers in humanities as tools, because well, there are complex instruments, very complex instruments to explore the data, and that means that I think that you need to know the capabilities and the limitation of the AR system in general and NLP in particular, to be able to interpret what the result of the system for if you want to use it in your research in humanities. So I think it is an important point. They are not. It is not because of word. It's well, you need to know exactly. It's not a push button.
Thanks. So what I propose is that if there is some question inside the virtual room, I know that Slava had some question earlier, and probably there are some questions inside the room.
Yeah, I think it was responded already, but still I believe, sorry, I have my helper here. So.
No, it's fine, don't worry. Very kind.
Yeah, so question was about semantic web technologies, and I really believe that that's something that
just leave it, it's fine. It will be
usually he's not acting like that. Sorry. Okay, so we will do it together.
Yeah, go ahead.
So my question was about semantic web technologies, and I really believe that it's not possible to solve all these global problems without linked data. And obviously, because we have a lot of data streams in different languages, so we need to link all stuff somehow. And of course, it's emerging now, and I really believe that's something that worthwhile to look at for every partner involved in COVID-19 museum and in Time Machine.
Yeah, but it's clearly an opportunity. So from my point of view, for example, one thing that I find interesting with respect to the testimony or even the interview or the news is the comparison of the news between all these countries. And I have a feeling that Valerie and Andreas, you have all the tools to at least compare how one information arrive at the news in different country or between different channels, and how it is received, how it is processed. And it's really interesting because I had the feeling when I was thinking to this project that it's the first time that we have the opportunity in a global way at a worldwide scale to be able to make comparison of the processing of an information in between the countries, in between the channels, and even to detect, for example, populism or detect false information, fake news or whatever like this.
Yes, I can. I talked very slightly about monitoring of and copy detection. So I can show you some slides. It was the end of my slide. I can show you some some slide to illustrate the idea. It's not a work that I do currently at IGN, but you can use a particular application of content-based image indexing and retrieval is copy detection. For example, you take this photo of Coluche, and it's not complicated to develop dedicated descriptors and visual similarity measures to be able to retrieve all these variations of the content. It is the same images here, is the same images as this one, but which has suffered from post-production. And so the same images appears in very different appearances. And with content-based image retrieval, you can work on such a topic. Of course, the first application is for plagiarism detection, but not only. I have here other examples. You can use it for image content and also for video content. It works very well because you add the motion component, and it works even more efficiently. And so you can also use content-based image indexing and retrieval to obtain statistical analysis about the dissemination of a content over the world, images, how are broadcasted videos contained in several channels. And so you can use also such kind of tools. For example, here you have one video, and here the same video, but broadcasted with post-production effect, with adding a logo, adding a text, and things like that. And so you can, if you monitor such kind of information over in a country or over the world, you can have a lot of interesting statistics. For example, you can focus on occurrence or on the frequency of occurrence of the diffusion of the content, of the location of this diffusion, etc., etc. And you can make very interesting statistics about what is important at a given moment in a given country about one event. And so by using these tools, you can do that. And of course, I was thinking about that for the COVID-19 museum. I don't know if it is interesting. Such illustration is interesting for you.
Yeah, sure. I think honestly, to be able to compare the news at on each channel between a country or between countries, inside the country or between countries, it would be of interest. One very funny thing, for example, is that now this pangolin story is starting to be controversial, and how it has been diffused in the world. It's just from free article, and even not scientific article. It's one letter, one non-scientific article, and one scientific article. And from this free information, suddenly the world has been covered by this idea that there was this pangolin story. And today it's obviously something which is considered not to be serious anymore. And how this information has diffused on at the global scale, at the world scale, is really of interest. And probably how it has been processed on the news also, it's of interest. News, written news, or television news. Is there a question? Yes, Juliette, go ahead. Yeah, I close my...
Is it okay? Voilà, est-ce que ça va comme ça?
Okay. Good.
Thank you. Do you hear me? Do you hear me? Yes, you do. First of all, I would like to apologize for being such a rookie in data science, and to thank you all for having made things almost understandable for someone like me. I have two questions, if you agree, and they all deal with something which we study with a German word. It is Weltanschauung, the vision of the world, the way society understands itself and the world around. My first question, I think, is for Andreas and Valerie, maybe. In the Time Machine Europe project, the past seems to be linked to cities. In your presentation, there were many cities and centuries, cities. Does it mean that you have many artifacts about the side? And does it mean that we will have a city-focused past vision? Because it has many consequences. I don't know if my question is quite clear.
So if I may reply, the focus on the cities is right now due to the bottom-up structure. So this is something that is essentially emerging from the current way how the time machine is recruiting its members. And this is why you see many cities, but these are essentially pilot projects. The aim is to later also build this on a broader scale. But the problem is that these projects will be more expensive on the one hand, and we have to provide infrastructure and software and tools and also guidance how to implement your own time machine. So once we have this, the aim is to build a time machine box that is essentially available to everybody who wants to build such a time machine. And then you can link yourself, your node into the network. And this would then enable also going towards citizen science projects and also going into a broad scale. But right now we don't have all the tools and everything available. This is why it's essentially also a result of our current science funding mechanisms, that they have projects of a certain size that gets funded. And if you want to make the idea compatible with the funding schemes, then you essentially end up with the local time machine concept.
Maybe I can add to complete. Yes, exactly. It's a bottom-up process. But right now, if you go on the website of Time Machine, you will see that a map of already existing local time machines associated to projects involved in those time machines. And if you add a new project in this website, you will see that you have the capability to link it with several areas. So you are not you can be involved in a project which can be applied with several cities, and not not which is dedicated to one particular city, and so you can declare your project on a whole set of cities. So it's the beginning of a more transversal approach.
Yeah, I can also add something to it. Yeah. So what we see now, I'm working, of course, in Netherlands, but we see a lot of usage of technologies created in Belgium, for example, and in France. So basically, we see attempts to create common infrastructure that can be reused in different countries. And I think it will emerge very quickly. And after we'll get some project success, everybody will switch to common infrastructure that will be built like that. So this is our future. It's kind of a continuation of globalization process in research.
Thank you very much. I have another question, a second question for Gilles and Jean-Michel, if they agree. Do you think that the use and the habit of using data science may change the way society sees itself and the world? I mean, for example, are we going to represent ourselves, the world, as risk managing, outliers, and so on? Do you think the concepts of data sciences are going to be social concepts? I don't know if you want me to say it in another way or to say it in French.
No. It's a quite difficult question and not so easy to answer. What can I say is that we are far from that, at least in France. In France, in my opinion, we work about that problem, but the French Statistical Society or the French Society, sorry, is not very prepared to the variability, to the statistical concept, and are very far from the fact that data science can change some things with respect to their philosophical point of view about life. We are very far from that. It's probably not so true for let's say England, but in France we are far from that. What can I say? Gilles, perhaps we can add something.
Well, I agree that it is that the society, in general, the society need an acculturation about what could be done with data science. It could be usually it is seen as angel or devil. So it's perfect. It is a verity, or it is well, garbage, and there is no middle. So because I think the society in general is need to understand exactly what data science could do and could not do, and so on. So as I said before, we should in order to understand, we should know minimum about what is data science and artificial intelligence, and to go beyond the names and to see exactly what's behind them, and about when you speak about statistics, it could be very complicated, but well, I think that it is I think that with constant effort, anybody could understand some notions about that, and to be able to well, anybody, and in particular historians and linguists and so on, and could then understand what is data science.
Thank you.
Yes,
Yeah, vas-y, Jean-Michel.
In France, the problem is that even decision makers has not enough concept of variability, statistical things.
Yeah.
And that's a problem. And we work a lot about that point. We do all we can, but it's a difficult thing. But Juliette, I totally agree with you. This new concept, this new view of what we can do with data is supposed to change, in some sense, the society and its perception of how making decision, not good or bad, but how to take a rational decision. But in France, at least, we are far from that, and I am quite afraid because we do a lot, but the situation does not increase in a good way.
Yeah, I would like to.
Sorry.
Yeah, I would like to add with respect to this topic that the education in French before at the lycée, I mean at the gymnasium, it's at a very, very low level in terms of variability and concentration, or everything is provided by mean or by things like this, or percentage in at the TV, and the education is really at a low level in terms of variability. Perhaps we could enjoy the fact that Slava and Andreas are not French, to know if the situation for in foreigners' country is a little bit better with respect to this understanding of the variability of what is a probability, what is statistics, and what is concentration. Andreas, perhaps you want to say a few words? If in terms of general population, if the concept around statistics and probability are in some sense a little bit how it is understood.
I think it's not that easy, in particular, to convey probabilities, but also with exponential growth, these concepts are not so easy to convey. What helps, at least to my experience, is using descriptive statistics, like when you map a probability of 20% to 20 out of 100 people or 2 out of 10 people or something like that. That helps in at least in the science communication. But yeah, it's not that easy, and you need to put in a lot of effort in order to communicate statistics and also mathematics in general. So when you show one equation, you essentially lose half of your audience with every equation you show.
And Slava in Netherlands or in Russia, how was it?
Well, I don't have any clear answer, of course, because like Andreas said, it's very hard topic. But well, at least we're trying to, so researchers in Netherlands, they are quite open. So they have common meetings together, and people from different disciplines are coming together to discuss common issues. And if you're able to explain your research to a person that does something else, this is where you can get success, because they can also get on board. You can get them on board, and they can contribute to your own research. So this is how we see it in Netherlands, and there are a lot of projects that trying to build from multidisciplinary teams, and this is basically now is kind of condition to be funded, to get people from different disciplines.
Jean-Michel, in the society group, the relation, this group about relation with society, do they progress? Do they have a relationship with other discipline or politicians or things like this?
Yes.
How it works?
Yes, we have a lot of relation with the population in general, and also decision makers. to increase their level of concept of variability, of analysis, or methodology, results. A lot of decision makers in France speak about machine learning, artificial intelligence, and things like that, and know nothing about that.
Yeah, that's clear.
Understand almost nothing, and give millions and millions to projects. But at the end, I have participated to some commission and things. You register, I can say that. Some people give a lot of money to do research in data science in general, and know nothing about that, and understand almost nothing. And that's big and big problem. But yeah, at the end, we try to play our role to explain some methodologies, a limitation, what can we do, the difference between descriptive things compared to inferential, to always consider that prediction are variable. With the COVID, it's an extreme case. Political decisions are taken without any consideration of any variability of the prediction model. So, what can I say?
It's really funny. It's the last decision was really funny.
Yeah, that's very strange. But we try to do a lot, but it's not so easy. Let me come back to one point with respect to the COVID-19 museum. Okay, can I, Yves, okay? The reason why I show you my works related to population genetics is to show an interdisciplinary works, because in our opinion, in the French Statistical Society, if we are able to create a data warehouse, let's say a data warehouse, or like the COVID museum project try to do, I think that this enormous source of information, of inspiration, is very important for interdisciplinary research. I think about a mode of research that integrates information, data, techniques, tools, perspective, concepts, theories from two or more disciplines. And this is important to now develop this type of research to progress in some specific disciplines. But I am absolutely not an expert of data managing and data warehouse. When I have big data, it's smart data. We have always smart data. We do method on smart data. The data warehouse associated to the COVID-19 museum, it's a big data, very difficult to annotate. And as you explain very clearly, Andreas, Juliette, Gilles, and other, and Valerie, it's very difficult to annotate, and the way you annotate the data also give a direction to the data warehouse. So how to be fair, I would like to fair in the two sense, with the data and other, I don't know if it's possible, but our opinion is that it will induce a lot of interdisciplinary research.
I will illustrate this your work with one